All right, as you guys can see, we have an explosion of parts here in the garage. Might have some inkling of what's coming. So, for a couple years now, I've wanted to create a remote control snowblower. So we're finally starting on this. We started with some kind of jazzy wheelchair thing. Um, got it all stripped down right now, and that was an old Craftsman snowblower. I got the track unit off of it. I still have to cut it down the center, separate the two, and then figure out how to mount the motors to it. Also got a good 12-force engine. I'm actually going to have to get another snowblower because this one I got literally just for the tracks. The whole front blower unit was blown up, so I got it for a good price. So what I need to do is, first thing I'm going to do is I have a Sabertooth on its way. I'll show you that hooked up in a minute. And first we're going to power this and see just how fast this moves. Right now those are direct drive, the motor to the wheel. And I'm debating whether I can do direct drive straight to the motor to the shaft, or if I have to put like a gear on there and a sprocket and have somewhat reduction, like a little bit. So first we're going to get that thing on remote control. We're going to test out, make sure all my electronics work, get the remote control going, see the speed, and then determine the gearing from there. All right, we'll be back. All right, so the next thing we're going to do is we're going to take the brakes off of these motors. They have a safety feature that unless an electromagnet is powered, by default, these wheels are locked through a brake at the end. And you do have a free mode, so you can spin it. But in order to get the brake off, we need that set so that the wheel is locked. Gears are engaged. There's two screws, one on each side. We take those off. There's our electromagnetic assembly. Now you have to clip these wires. There's two screws here that go into the casing to keep this from spinning. And then there's one that goes into the end here, and that's been Loctited. So what we need to do is we will get our proper T-wrench, and because it's geared so low, there's no real way to hold on to the tire itself. So we just put a breaker bar on the nut, and we'll hold this tight as we spin that off, and the whole thing will come right off. All right, so we're starting to get ready to do a little bit of wiring here. This is the disconnect that came with it. I don't want to cut into the other end of the harness because I might try to sell the controller. They go for like $130 or something on eBay. So I had to find something that would match this because I like having a quick disconnect. So this is, I got this off of Amazon. It was like $12, came in a pair. 120 amp, 6 to 10 gauge quick disconnect, and it fits. Everything is the same size, hence wire up for the controller. We went with a Sabertooth 2x60. That's going to be a little more powerful than we need, but better safe than sorry. And so basically, we'll show you how to wire all this up in a minute. All right, so we got everything wired up. We got our batteries wired as they originally were. You can test it at the thing to make sure you're getting 24 volts out. This is the adapter that I put in. I put in these 6-gauge cables, probably a little bit heavier than I needed to. I didn't check to see what those were, but a little harder to work with. So I installed Kill Switch, just so I can knock off all the power. And then, so the installation of this thing is pretty easy. Right now, we just have it like, it's secure, but it's, temporary. Now you have your main power lines coming in, and then you have your two batteries, or your two motors. And then for the back part, so this little dip switch down here, you can change the settings. Right now, I have it set up for RC mode. And I'm using a small RC transceiver. This one is I think it's an FSR or something. I don't know. Here's the controller for it. It is an FST6. This whole thing with the controller there was $50 on Amazon. It's a decent controller, can do helicopters and whatever, planes. So basically what you do is, one of these is the battery. it says battery here, and then you have channel 1 through 6. So I have it set at channel 1 and 2. And basically, from the battery wires, that's where it gets the positive and negative. And then we just plug in the sensor wires for the 2 channels that we're using. So we'll give it juice. And then we'll turn on that controller. And so now, forward, both wheels are forward. Back, both wheels are back. And then if you go left or right, the 2 wheels will spin opposite of each other. So now we're going to, and in terms of like setting up this controller, you can watch some YouTube videos on how to set it up. It actually came pre-configured with everything that I needed right out of the box. I didn't have to do anything, but there is like there's a lot to know about this thing. So you might have to watch some videos on that. All right, so we're going to put this down on the ground, and we're going to see how fast she goes. That's full throttle, full takeoff. I think the direct drive will be okay. All right, so here's what we found for our snowblower front end. It's got a 26-inch width. It's kind of small. It's not that big. It's got a 9-inch duct in there. I was a little bit worried that such a wide thing and such a small duct would kind of be a problem. My other one is significantly bigger. But I've been running this through some tests. I'll show you those in a minute. This seems to be throwing it just fine. 8.5 horse engine, had plenty of power even on the heavy stuff.
Yeah. $14 for.
I don't think I'm going to do this, but I'm going to show it and for the next guy. If I was going to use like the Deep Lug snow tires that came off of the other one instead of tracks, I think I could get away with doing this. That frame fits
just inside the Jazzy frame for the old wheelchair. So, I mean, it's hitting right here. But if I were to cut some of this off, send it down in, and then weld it to the existing frame, I think that'd be a pretty good caddy. And then you just have to figure out a way to get the tires to mount to. There's plates on the back of that. So I think I really want the tracks. And even though this is already 23 inches on the outside, I only have 26 to work with. And the tracks are like 6 inches wide a piece. So there's no way to do it with tracks. I can't be that lazy. But if I was using tires, it'd work. If you ever wondered how these track mechanisms were, so there we go. 2 metal plates, 1 on each side, bushing on the outside, metal, sprocket in the center, and then the sprocket gets its drive with a bolt going through. So that's the way it was on both sides. At the point where we're going to talk about powertrain. Now, my first thought was we knew we could do a direct drive speed-wise. So my first thought was to cut this off about here, and then take some of this material, board out so that fits in nice and tight, about 3/4 of an inch deep, weld it around. This will be cut off about here at that point. Then, holding it by that surface, we could bore in and get the 17 millimeter dimension that would couple it to the motor. Now that has a keyway. So in order to do that, what we would do is we'd mill a slot in here because I don't have a broaching setup or anything. So we'd take like a 6 millimeter end mill, go right down through into the bore, then take another end mill and clean this off so we had kind of a larger flat surface, and then weld a plate on and put 2 sets of screws. So we'd have a rigid coupling. The problem with that is all of the weight would go directly into the bearings of the motor. and they're not really meant for that. I mean, they're meant to hold like a 300-pound person, so 150 pounds aside, and the wheel sticks out about that far. So by the time the tracks and everything, you'd be out to here, so you'd really be torquing on them, and it would work. It'd be okay for a while. I think it'd probably be okay for as long as I need it, but I'm going to do something a little bit different. So we have the existing hubs here, and what I think I'm going to do is I have some of the chains from, the 2 snowblowers that were sacrificed. I'm not going to be able to use this finished gear because it's a little bit too big. So I ordered a couple more and that were like 3 inches. And I ordered 2 finished bore gears. And then I ordered 2 flat gears or sprockets rather. And what I'm going to do is I'm going to bore the sprocket out so that it fits this hub. So then I'll be able to use this hub as is, and I'll just be able to bolt the sprocket right to it as if it was the thing. And that'll give me a little more room to play inside the frame of the housing as well. All right, here you can kind of see more what I'm talking about. We're set at 25.5 inches. Max he can be is 26. You can see just how much of an overhang there'd have to be coming out of that shaft. And those bearings are kind of small, so I'm going to offload that torque instead of going into those casings, which are kind of expensive. It'll come out and there'll be a bearing here and 2 bushings, basically, one here and here and one here and here. So the other aspect of what I wanted to cover is there's our old frame. I have the 2 bushings in that. What I'm actually going to do is I want the base to be independent from this top half because I don't know where my balance is going to work out. I mean, we have the big weight hanging off the front. We have the engine on top. We have the motors out here somewhere in the back, and then we're going to have 2 batteries and an electric box, and I can't really predict. I'm also going to have an electrical actuator so that I can pivot. I want to be able to pivot the whole top part with the engine so that I can control the scrape angle or to clear it in case there was a buildup of ice and it was just digging in. So in order to get all of those things right, you can see that's where they set their pivot. And actually on this model, it wasn't quite right. It should have been back a little bit more. There wasn't enough pressure on the scraping edge. Maybe they made it for like old ladies, so it wouldn't be hard. I don't know, because it was a little bit smaller unit. Anyway, so what we're going to do is we're going to cut her off about there. We're going to make this independent from that, and we'll basically have 2 mounts. We'll have a pin on each side so that whole top unit can rotate, and then we can shift its forward and back to play with the balance and decide how we want that to go. All right, so now it's time to talk about drivetrain. For our axle, we're going to use a set screw gear. This already has a finished bore. I'm not entirely sure if I'm going to mill a 3/16 keyway and then use the keyway on this, or if I'm going to weld like just another thing off of this and put a bolt through it like it was with it for like a shear pin. Figure that out in a minute. Here is the existing hub off of like the Jazzy wheelchair motor, and I've decided because this doesn't give me a whole lot of room. If I were to I have some of these flat sprockets with a machinable bore, so I'm gonna mate these together. But if I just do it like up against this plate, I'm still gonna have to do some work to this. I'm gonna have to turn this down and stuff. So I think what I'm actually gonna do is I'm gonna cut off this limp. I'm gonna I'll turn it all down to this thinner diameter, and then I'll probably cut it into at least 2, maybe 3 pieces. I really don't need any more drive, engagement than this much. And then that would allow me, then I'll turn a little shoulder on that, then I'll bore that out. And that will give me some spacing so I can set where I want it to be, because the frame and everything is going to be a little bit tight. That'll give me more options than if I were to only put it against this back plate. All right, so we've turned off the rim. First, I did this in a 3-jaw chuck. That's actually the bit that I did it in at a little bit different of an angle. That way I didn't have to turn all the stuff off, and maybe I can use the metal for something else. It would have been nicer to have a little bit sharper, like a little bit steeper of an angle that I could have got in there, but didn't really care. So now we switched over to the 4-jaw, and we're starting to chuck it up and get it to run. Now, when I start to turn like the steps and stuff, it all has to be, dead on, because I don't want any wobble in my gears or anything. So I switched to the 4-jaw because the 3-jaw is always going to have a little bit of wobble. And so I squared up on the 3-jaw. I get it to run concentric. I'm going to go for this inner hole, and I do it in 3 stages. First, I get the piece in there, and then I kind of line it up to, where this line is in the chucks, that inner hole, and I get everything so it looks pretty good by eye. Then I put a cutting tool in, and I set it on the inner bore, and then I rotate it around, and then I will adjust the jaws left and right as I get closer and closer to center. You can do it pretty good by eye. And then the final step is I'll take the tool bit out, and I'll put in a dial indicator. And at that point, I'm quite close. I'm probably within 15 thousandths or something. And then all you have to do is just barely tweak the jaws just a little bit, and you'll be able to get it up. That's the fastest way I found to get things to run true with a 4-jaw. Everyone has their own technique. That's mine. All right, so there's one of the finished pieces. I will cut it off about here on the bandsaw, then clean up the back of it. And then we'll bore this out to the 1 1/8 that is. And then we'll weld the two together. All right, one other stupid trick is, how do you cut such a small piece on the bandsaw when you can't really get this piece all the way over there, and also it has this lip. Well, that's not helping anything now, is it? So it has this ridge, that's above this, so it would want to tilt back. So first you got to put a washer down under there to keep it, straight across. Then we put in some wood and another spacer block so that we can get a good clamp force on it. And for what this is fine. Sometimes I also have to weld another piece of stock onto the end of this. Like if it had been a bigger, heavier, thicker piece or something, you can also weld more stock onto the end and then cut it off and then just cut the little bits of tack that you put on it. But this will work for now. And proof that you can get good results with shady techniques.